Welcome to AI 102. My name is Danny Finch. I am the marketing and communications lead here at ArtCurve. I will throw you over to Jeremie pretty soon here, but I want to do a little bit of housekeeping first. So questions will be answered at the end of the presentation. We'll have about 15 minutes for questions. You can pop those questions into the chat. There's a Q&A chat at the bottom of your Zoom screen. It's got two little chat kind of bubbles. And if you click on that and throw it in there, I will be able to moderate those questions at the end of the presentation. So this AI 102 webinar is part of a 10-part series that we're doing here at ArtCurve. We are looking at AI kind of starting in a really broad perspective and getting a little bit more narrow as we go. So we started with AI 101. We did that one last month with Mike Morley and Pete Tunkes. Some of you may have been there. Mike and Pete covered the basics of AI, so where AI shows up in our day-to-day lives, the history of it, and kind of how people in our backyard right here in Calgary and Alberta and Canada are implementing AI into their businesses on the day-to-day. So Jeremie's going to go a little bit deeper in here, talk a little bit about the return on the investment in implementing AI, but I'll let him go into that. He's the expert. So before I throw to Jeremie, I wanted to give a little bit of an introduction to Jeremie and his background and his expertise. So Jeremie is our Director of Advanced Analytics over here at ArtCurve, and he is a very experienced data practitioner. His focus is on business outcomes, and he's spent nearly 20 years working in data and analytics development. He's got experience across industries, including healthcare, energy, finance, and more. You'll hear a little bit more about that when Jeremie presents. Jeremie holds a Bachelor of Science from the University of Calgary in software engineering. And when Jeremie's not working, which is often, he and I will often ping each other after hours and get some work done. So he's a bit of a workaholic, I think. But when he's not, he's an avid backcountry skier, a mountain biker, a mountaineer, and a paraglider. So I'll let him tell you a little bit more about that if he is curious. I'm just seeing a little question here that I will address as well. The seminar will be recorded. Yes, we are recording it right now, and it will be posted to our YouTube channel probably sometime next week. This whole series will kind of roll out over YouTube over the course of time, and so you can watch for that there. But hopefully that won't deter you from sticking around, because Jeremie's always great live. It's always nice to have the live interaction here. All right, so without further ado, you don't want to hear me talk. You're not here to see me. I'm going to throw it off to Jeremie. I'm going to disappear, and I will come back to moderate some questions and answers. So Jeremie, take it away.
Thanks, Danny. Much appreciated. So nice to meet you all. Thanks for joining us today. I really appreciate everybody taking the time. It's fantastic that there's this level of interest. And as Danny mentioned, this will be recorded, so hopefully the thing in my teeth will forever be recorded, immortalized on YouTube in the ArtCurve channel. So just to give you a bit of background, so yeah, Danny did do justice in the introduction. I've been working in this space for a long time. And today what we're going to do is we're going to talk about the initiatives or the domains and where ArtCurve sees AI gaining steam, where we're implementing these solutions for clients, where we see pickup across domains, and how they help drive outcomes. So the goal is to be very, very tactical in what we're talking about today. So just a bit of an agenda. Danny's kind of already mentioned the 10-part series that we're doing around AI. So as she mentioned, I'm the Director of ArtCurve Advanced Analytics, or AAA as we call it. And in this series, we'll be touching on a variety of things, like how to get your projects off the ground, what are the roadblocks, tangible examples like we're talking about today, that sort of thing. We'll talk about some brief guidelines to getting started with projects. I think a lot of the feedback that we get from clients is, okay, if there's a thing we want to do, how do we even approach this? This is something that we need to do. We'll talk about, obviously the real world applications of these tools, where clients are seeing the best pickup and the best ROI for those applications. And then, of course, actually calculating that ROI and how you assess that. That's a bit of a ethereal topic that a lot of people struggle with. So, the point of the presentation today is to really illustrate that these are not really just solutions looking for a problem. The prize today is to actually address the problem and capitalize upon the opportunities there. So as far as the next session goes, just throwing an idea out there, we'll probably cover something like success factors for AI and ML projects. That said, if anyone has feedback as to what they'd like to see or what they'd like to hear, or anything that we might see in industry or be executing upon, please let us know and we'll adjust our sessions accordingly, because these are for you. So AI in our backyard. Mike and Pete kind of touched upon this in the last presentation, but I really want to reiterate this, that these solutions are everywhere. They're all around us, and they're only really increasing. A lot of them are invisible. Some of them are more visible than others. But things like marketing, customer segmentation, and engagement. That's like, think big tech. Think Facebook. That's been around for a long time. Those technologies are only becoming more mature. Security, just to kind of name some examples. So cameras on site to detect, if a vehicle is on the premises or if it's a person on the premises. Differentiating between a light vehicle or a heavy duty vehicle or a vehicle that's not supposed to be there, that sort of thing. And of course, we could talk about, customer service, customer experience. Chatbots for self-service are a great example of that. That technology's only been maturing. So there's a couple of examples of things that are around us every day. Let's talk a little bit about getting started with AI and ML. So what we want to do today is we really want to talk about identifying these opportunities and how to go about identifying those opportunities and how they've led for some of our clients to real world tangible outcomes. So maybe I'll back this up a little bit and say that the most promising opportunities for ML are those that elude the easy codification of rules, but are nonetheless tedious for a human. So something where you have 50 variables for input into a process or something. No human can really look at those variables and find the optimal solution very easily. That's what the machine does. So tactical solutions, we don't have to solve the big problems. You can solve several small problems and yet achieve an outsized outcome. Defining an existing business process and a clear ROI. Some of the feedback that we've been given and we have given to clients is really, yes, you can start with some net new process, but if you're starting with something net new, you have all of these additional hurdles that you then have to overcome. So that means, like, you have an OCM challenge, you have the creation of an entirely new process that has associated risk with it, if you will. So understanding where there is something and how you can capitalize on it is definitely makes the project much more likely to be successful. Data value stream analysis. This is something that AAA has codified into our service delivery. We're advanced analytics. We're not just AI and ML. And the reason for that is, often we run into projects or people or clients, whatever, like, we want to do this. We think we have this data. Okay, do you? Do you actually have the data that you need to do the thing that you want to do? This we go through this process to help identify gaps in what the organization thinks it has and what it actually has. And that's pretty valuable because that ends up either facilitating a business process change upstream, or maybe even taking the initiative off the table, or redirecting the initiative to something that might be more tangible, more likely to succeed. Um, Project positioning, we speak a little bit about this in terms of, here's a project, you have to sell it to your internal stakeholders. How do you sell it to your internal stakeholders? So augmenting and not replacing the human is a pretty big part of that. I mean, there's a lot of noise, word confetti in the industry that, AI is coming to take your job. So there are plenty of fears to be assuaged, sort of thing. Um, framing the initiative within existing behaviors. So this is really kind of comes down to knowing, back to the business process and clear ROI. Is this something that the business currently does? Is the business okay with failing rapidly, iterating, that sort of thing? You might want to pick the line of business that's maybe more mature. And then finally, the solution maturity. Solution maturity, a lot of these ML algorithms, particularly, and the AI algorithms, or some of the AI algorithms, are already very mature. These are no longer academic things. They are tried and proven techniques that can be used in industry. So with that, I'll get into a couple of examples. I will apologize, we're a little bit oil and gas heavy. But that's the nature of where we are in Western Canada, but we will talk about kind of some other examples. The first one I'm going to talk about today is blend optimization. This is something that happens across resource industries generally. So oil and gas of varying stages: upstream, midstream, downstream, mining, that sort of thing. So the premise behind blend optimization is it allows for inputs and outputs of a process to be optimized. So for instance, say you run an oil processing facility, your product from that facility has to be within a certain spec in order to sell it. And what you might do is you might want to adjust that spec for maximum profitability. This appears in retail gasoline. So for anyone in North America who's bought gas at say a Husky gas station or something like that, or many gas stations, you'll have ethanol blended into your gasoline. And there are environmental reasons for doing that, but there's also other things like octane enhancers, metal deactivators, and antioxidants, those sorts of things. There's a great importance to how you blend, because it's not really a static process. It's not like, okay, we found the optimal solution once and we're going to stick with it. And a great example of that is ethanol and retail gasoline at the moment. If anyone's looked at the price of ethanol in the last 8 months or so, or maybe a year, it has just about doubled. So that changes the economics of what's happening there. Condensate blending, oil and gas midstream condensate blending is another example of that, where the variability of product changes considerably, and being able to blend that product as it's fed to your customers is of crucial importance. There's a lot of opportunity there. Mining ores for milling. So if you're running a mine, the ores of interest are varying quality in different places. So you might change the way that you feed your ore to your mill, or what you do with that ore. Of course, there's also smelting and refining, which are cousins in the mining and oil and gas space. So that might be smelting. I guess you can think of it this way: they're both like baking a cake, and you can tune the ingredients. You can add more salt, you can reduce the salt, you can change certain ingredients. So this is very much, again, based on the price decks of the product that you're putting out, the feedstock that you're putting in, the availability of inventory. So you have this much salt to put in your cake, to use that analogy. So it's very much a living process. And the ROI in this space is goes pretty much right to EBITDA, goes right to margin, because the capital dollars have already been spent for these facilities. Like you already have your oven, if you will, and those revenues just go straight to the bottom line effectively. Since we're in Calgary, we got to talk about E&Ps, exploration and production. I know we have a number of folks on the call who live in that space. There's a lot of activity in this space, and I think given the energy transition and what's going on, capital constraints on the industry, there's going to be a lot of very interesting things happening in this space in the next decade or so. We already see that happening. So there's a lot of focus for machine learning on enhanced oil recovery. So, that might be artificial lift, whether it be gas lift, water, CO2, SAGD. SAGD is really the big one. And I'll maybe kind of go through some of those examples to explain where that opportunity may lie. So a great example in the Montney is gas lift, an unconventional gas lift. And the idea behind gas lift is that you put gas down the hole of a different density to create a gradient within the hole, and that gradient will help carry additional products up for recovery. And what you have to do there is you have to find the optimum rates along with a lot of other variables in those assets to recover more product. So it's really about like high grading how you recover product from the capital that you've spent to drill and complete the well, if you will. With the gas lift example, one of the reasons that we include the R-curve analytics part to it is there are lots of feedback mechanisms in these types of engagements where you might put gas down hole to recover more product, but in doing so, that gas has a different temperature, changes the temperature gradient, which in turn causes waxing, which means that you have to spend a bunch of time taking everything offline, removing that wax, incurring additional cost. So what you've then done is you've created revenue in one place, but you've incurred operating costs in another. So taking a holistic picture of what these algorithms do in the ecosystem is of crucial importance. SAGD, I'll just briefly touch on that. That's the idea there is downhole temperature sensing, DTS, is really looking at the temperature gradients within heavy oil reservoirs and really identifying where to allocate steam. So you might allocate steam to a certain part of the reservoir. It might have effects that are delayed. There are a lot of variables there, but there's a lot of potential uplift opportunities there. Product routing is another example where in order to do something like gas lift, if you're using gas to put down the hole and then you have to recover that gas, you're inherently using a bunch of your capacity in the products that you're recovering, which reduces the volume that the facility is able to process in effect. So it has a direct effect on capital efficiencies. But these things kind of all go in tandem, right? So you can do enhanced oil recovery, but there's a routing challenge there as well. They're very tied together. Chemical usage is another great example of who uses what chemicals and where. So things like corrosion inhibitors, that sort of thing. And chemical usage within this space is very much here's 50 variables, and usually the operator is very much like, okay, well, this is the thing that's always worked best for me. So this is the thing that we're going to continue to do. And it turns out that that's not the case, that you can optimize on a smaller set of variables. A little bit more on midstream. We see a lot of uptake in facility balancing, particularly. So really understanding what goes into a facility, what comes out. This might be like dropping the C's out of your natural gas streams. So if you're recovering, say, butane or propane, really identifying if those processes are working as they should. Did you actually recover as much as you needed to? Meter proving is another one. Meters generally begin to have errors over time. Most of these organizations have measurement teams who will go and prove these meters. Proving a meter is effectively saying, like, is the thing measuring as it's supposed to, which you can then go and correct it. Where we're seeing that opportunity is being able to really identify, okay, you have a facility with 50 meters, here are the 5 that are causing you problems. And you might be able to suggest those 5 to that measurement team, and that's what they'll go look at. Sensor drift is something that I mentioned here in midstream, but it's really applicable all over the place. And that's really understanding if the sensors you have, the SCADA systems you have on the facility are slowly drifting. And this is a very crucial component of machine learning, because those are the inputs to the thing that you're using to learn. And if they're moving, that's a bit of a problem. They're usually very insidious because it's like a frog boiling in a pot of water. You don't really notice until it's too late. And it has a direct correlation with eroding margin, or sorry, eroding return on these projects. Natural gas demand and load forecasting. This is really mostly natural gas, but also electricity. The same kind of the same challenges sort of apply. Usually this starts with demand forecasting. Demand forecasting is, okay, how much power do we expect this sector to use, or how much energy do we expect this area to use? How do we front load our business or our plants to deal with that incoming demand, which, you know, to some degree, we've seen manifestations of those challenges. You know, like Texas is a great example recently. So there'll be a lot of interesting change there. So demand forecasting in terms of, like, let's say natural gas supply has a bunch of components. And I really want to dwell on the natural gas supply component at the moment. So when you understand demand, then you can begin to optimize things like line pack. So line pack is how much pressure and how much gas do we have in the system? What's the expected drawdown from retail, and how do we optimize that? And that's then tied to compressor optimization. So you need to compress the gas to put it in the pipeline. You have things that you can control, like load and throughput and suction pressure. And you can make recommendations for those set points. None of those components operate in isolation. Yeah, they operate as a system, and you can make recommendations to the system. The way that typically works, or many of these algorithms work, is they make recommendations to the operator, and the operator can choose to follow them or not, which implicitly creates many challenges. Let's talk about something not oil and gas, architecture and real estate. There's been a lot of interesting things happening here recently. So commercial retail has to be probably one of the more fascinating spaces in the COVID era we're living in at the moment. So really understanding building utilization. And we're starting to see this with some of the more sophisticated buildings where you can control HVAC systems to a higher level of granularity. You know, these are the people that are actually in the building. We're only going to turn on floor 10 and not the whole building. There will be significant ESG pressures in that space as well, as buildings are a large consumer of electricity and a large emitter and so forth, right? Product placement. This might be something along the line of understanding client cohorts that walk by a commercial real estate location in a facility. So say you run an airport and you're leasing a space to a coffee shop, like be it a Starbucks or a Tim Hortons. You can begin to understand who walks by that space, generally who those cohorts are, and what that space might be valued at. And the retailer may better understand what their target audience really looks like. Spatial design, how people use a space. Do they use a space? I mean, we've all seen it, dead spaces within buildings. This is a space no one ever goes to. Why do we even have it? Can we repurpose it? Uh, Power consumption management, again, related to the commercial retail HVAC example. Do we consume power in non-peak hours? The concept of virtual power plants is becoming very interesting, where there are a lot of these facilities, midstream buildings, you name it, that are both drawing power and committing it back to the grid. Third-party data. This is if you have vendors who are providing you with PDF copies of information. I mean, this is something that we run into in every sector, but we see it also in architecture and real estate. How can you capitalize on that data? How can you extract it, and what can you do with it? That's something that we've built significant competence in, and we have a lot of interested parties in capitalizing on that information. Finally, environmental and risk management. So extracting features from unstructured data, which is again similar to the PDF thing, but like let's say you're buying a building or you're buying a facility of some kind, and you have 20 years worth of environmental reports that have water pH in them, and you want to understand if the building or the facility or whatever it happens to have been changed the water pH. This allows you to capitalize on the data and do that. Engineering and construction, I'll briefly talk about this. Material management, really identifying the assets that you have, the materials that you have, so pipes, valves, other commodities. That might be stuff that you actually want to sell, or stuff that you have internally that you might be able to use. We found that a lot of clients have really a poor understanding of what they actually have, very much like the data that they actually have. What inventory do they actually have? Combining internal data and external data. Usually in an in an engineering project, you'll have lots of subcontractors. You might need to kind of combine that data and understand, okay, what is it that I really need? That might be like getting specs from third-party vendors, that sort of thing. And then P&IDs, process piping and instrumentation, or really any kind of instrumentation. It's more like the IDs. This is where an engineering firm might look at a facility, decide where to put the instrumentation, which is again sort of critical because that's the instrumentation that will feed those machine learning models. But being able to identify, like, okay, well, this is where we've used these materials or this instrumentation before. This is where we might use it again, that sort of thing. Other industries, I'll just briefly kind of touch on logistics. So routing, finding the optimal way to ship products. This is sort of tied to a market analysis logistics use case, where if you have a facility, say like a third-party blending facility or something to bring it all together, you might look at where your feedstock is coming from and how you might be able to capitalize on some of that feedstock. Identifying the market share that you're not addressing, competitive analysis, who's competing in the space, and then finally, like logistics planning, like, where do I send my trucks? Where should I set up my loading yards? That sort of thing. Within the financial space, we didn't really talk a whole lot about finance. I can probably say that the financial space is the most sophisticated. A lot of these techniques have been around for a long time, like marketing, foreign exchange, optimization. That's something we see quite a bit of. Trading automation. We've recently completed a project that is pretty neat, where it's like an intelligent limit project that allows traders to complete a trade at the optimum time based on the FX and other market conditions. And that's immediate revenue. So that's been very successful. Fraud detection, again, one of those things that's been around for a long time. I mean, Visa and MasterCard are pros at that, but that's kind of table stakes for every financial organization. Lending approval, there's a lot going on in this space at the moment. And this is really like all lending is generally based on credit scores, but you can get much smarter than just credit scores. It might be profitable to lend to someone with a lower credit score with the wealth of other information that's available. And then insurance, processing unstructured data for claims, and it's very similar to fraud detection, understanding where you might be able to capitalize on better insurance techniques, if you will. So what about the ROI? So those are my examples for the moment. Please feel free to offer some feedback or guidance or questions, anything that you have, throw it in the chat for Danny. Let's talk about ROI. So when to calculate? Well, obviously, when you scope out the project, you should be able to estimate that ROI. But I think the more important thing that we find is being able to continually estimate that ROI. So, you have an idea of the value that you've provided. Now, how do you sustain that value? So if you were to go back to the blending example, you might say, okay, this is the product that we sold where we did blend, or we did use that algorithm. This is the product we sold where we didn't. So effectively, you can then kind of capture the theoretical maximum performance, or the uplift, if you will, the product uplift. And that makes it very concrete. That puts it into a framework that your leadership can really understand. Like, okay, we would have done this much more had we done this. So there's a value erosion component to that as well, where something gets put into place, and for whatever reason, the data changes, the people change, the process changes, the value then gets eroded. So there's something to be cognizant of there. Real world ROI. We're working with a large mining company at the moment that has hundreds of these initiatives. And they have added 500 mil in value in 2020 to their bottom line, straight to their bottom line. They've spent a little bit of capital in adding telemetry and correcting upstream issues, but generally it's gone to the bottom line. And they're expecting to double that target in 2021. So it's kind of astounding. The industry average, not everybody's kind of created the same. The industry average for returns can be, I'll quote, 14 to 22%. But then mileage may vary, and we'll talk about that just a little bit more. Last thing I want to talk about before we wrap up is this is not a black box. R-Curve, it's in our interest to educate clients, help them sustain the products that are built. And one of the most common detractors is, this is a box that you've given me and I don't really know how it works. And that doesn't really help anyone. So we're there to help our clients own the solution, and we're there to support it. So that's kind of what we do. And we're there throughout the sustainment component of the project, where you might have something that's been implemented, we can kind of help sustain. And then, of course, managing the data changes and business process changes. Client feedback that we've gotten. So I've shown you a bunch of examples. Some might work for you, some might not. The differences, the mileage may vary. Differences are a result of market sector, digital maturity, engagement. Many of these algorithms make recommendations to humans. And the big part of that is, okay, well, now you have the information. Having it does not dictate success. Success is really dictated by, do people trust the information? And that's not changed. That's been the same the entire time I've been in industry, at least. The common pitfalls, this might be a topic for another AI session. You might have 5 projects. 2 may never get off the ground because you don't have the data. 2 might break even or do better, mildly better. And then, one of them might be a home run. And that one that's a home run might make up for the other 4 that were kind of break even. So the mileage does vary. And then finally, the accumulation effect of these projects. So a lot of these initiatives kind of go together, and you get a small one here, a small one there. How do they work together? They might work in different lines of businesses across different people, but they're congruent to a goal. So that's generally the feedback that we've gotten from the market and we've given to the market, and that's kind of where we see the space today. That is my dog and pony show. I have not been watching the question thing.
I have though. Hi guys. Jeremie, we've got a couple questions. Just a reminder, you can put them in the actual, there's a question and answer chat. I see a couple of them coming through the chat. It just might be easier to manage if we get them all through that question and answer chat, but I will address the two that we've had in this chat here. So first off, Jeremie, has there been a desire to use these models and data to drive digital twins?
Oh, absolutely. I mean, that's been talked about for a long time. And yeah, really understanding kind of the theoretical maximum performance of an asset, how an asset could be performing, as opposed to how it is performing. So absolutely. Modeling the digital twins, like the technology to do that has become also more mature. I mean, there are a lot of tools out there that help with that. But yeah, understanding what the theoretical maximum performance is basically digital twins.
Awesome. Hopefully that answered your question, Michael. I've got another one. What will be the impact of ESG on these technologies? So maybe Jeremie, you can talk about that a little bit.
Yeah, sure. I think like there's a lot of industries that are going to feel market pressures, ESG pressures. Maybe I should back that up actually. When we say ESG, I mean environmental social governance. So there's a lot of organizations at the moment that are trying to understand, okay, what's the ESG in our supply chain? How can we go get that data? So, a good example of this is data refinement and looking at purchasing history. So if you look at your credit card statement and the detail for your credit card statement, you have like this weird text that is kind of like acronyms for what it was that you bought. And it's sometimes hard to tell what that was. There are quite a few companies out there at the moment that are trying to figure out like, okay, what did I buy? And what ESG category did it fall in? And what does the ESG of my supply chain look like? I mean, like that's also applicable to the oil and gas space. I mean, the Canadian oil and gas space has been touting that for a while now. Like it's greener, it's a higher ESG scored industry, that sort of thing, right?
Awesome. All right. Thank you, Jeremie. Hopefully that answered that question. I've got another one coming in. This one's about artificial lift optimization. So when we're talking about data-driven solutions, are we talking about supplementing physics-based models with the data-driven solutions or independent data-driven models suggesting optimizing artificial lift?
I think it's more additive to the physical models, and there's a lot of back and forth in the space about that, right? Particularly like in the artificial lift space, and like how do I better answer this question? The physical models are there and they're somewhat understood, but they're somewhat erroneous. So I think they can add an additional perspective, but you can't create a model and ignore the physics, because there are certain knowns, and I think it's more supplemental to what is already known. And I think that's kind of crucial in facilitating the buy-in and the trust of the product that's delivered. So in other words, if you're trying to create something that's unrelated to the physical properties of how a process behaves, the engineers or process people who run that process are not going to buy into the solution that you're trying to deliver, because it doesn't adhere to the first principles of the products of that process, if that makes sense. So yeah, I think it's generally more additive. A lot of the other spaces that we see, so like in the mining space, the machine learning algorithms there are kind of a direct result of the physical system modeling that's already been done. Like, we know how this machine works, and if we run it kind of in this way, we get this result based on like the physics of the rock that you're crushing or blowing up or whatever, right? So hopefully that helps clarify, but I'd be happy to talk about that more with whoever asked it.
Awesome. And we'll tell you how you can contact Jeremie at the end here. So here's another one. What domains are the most advanced and who's ahead of the pack when it comes to this space, Jeremie?
I'd say the financial sector is kind of ahead of the pack. And yeah, the financial sector, and that sort of includes fraud, liability, but I think there's a lot of pickup in the legal sector, particularly at the moment, and really understanding unstructured data, and being able to like parse and do topic modeling on what's in the legal space. I mean, like, Clio just raised another big round of funding, so there's a lot going on there. Fraud and credit risk scoring, there's a lot going on there. I mean, we've seen that here in Calgary. There's been a bunch of capital allocated to that space. But I think that, the oil and gas resource industries, they're catching up pretty rapidly. Forestry is doing some pretty interesting things. I think it's been a strange COVID year for a lot of industries, but the best time to get started was 20 years ago. The next best time is now. And I think there was a lot of sitting on hands earlier in the year, and now a lot of folks are starting to realize that, like, okay, well, we've got to do something. So, there's a lot of opportunity on the table there. But I guess I should actually say that the research sectors and the health sectors are also fairly far ahead.
Right on. Hopefully this answers that question. We've got time for a couple more questions here. If we don't get to your question, like I said, we'll throw up a screen that has Jeremie's contact information on it, and you can reach out to him on LinkedIn or email us over at RCurve. And we can get to some of those questions. I think we've got time for a couple more though, so I will kind of do them in order here. So this one says, what do you find the biggest challenge is with integrating into existing client environments and client workflows?
Yeah, that's a really interesting question. None of these things really exist in isolation. I think that the largest challenge is understanding kind of the bigger picture of how it fits into the business, right? So if you look at the digital maturity of many businesses and what they have in the traditional analytics and reporting spaces, they know a certain amount about their business. And it's really kind of fitting these types of projects into that ecosystem of things that they already know. Right. So understanding, like, okay, this is where you're going to see the impact of this algorithm. So, I gave a couple examples around uplift. Like, oh, we're going to see more ore or more metal recovered, that sort of thing. Being able to frame that together into a kind of a more comprehensive picture. The commoditization of like what's gone on in the traditional analytics world and the advanced analytics world, like that gap is closing. The tools have only gotten better, cheaper, faster. You can have a traditional data warehouse on Azure or AWS or whatever, and you can fit these pieces into that warehouse. The kind of the key difference with the machine learning models is that they feed back into a system. So they'll feed back into an app. You might take these recommendations and you might put them into a SCADA system or something like that. So it feeds directly back into the business where a lot of this other information kind of comes out. But I think like framing it into the bigger picture is where a lot of the opportunity lies. Did I really answer the question there? Was that really the question, or did I just drone off?
No, I think that we did. If you need a little bit more to whom answer the question who answered the question, you can connect with Jeremie and we can kind of dig a little deeper into that one. All right. I think we have time for one more. There's a few more here in this Q&A, but we'll take one more and then we'll wrap it up so that we don't eat up overtime of your lunch hour. So this one is also kind of client related, and it says, in a scenario where there's a currently low data utilization company, what order would you take? So it's kind of a 3-part. 1, existing clean data, so quick to complete, low ROI. 2, existing dirty data, longer to complete, greater ROI. And 3, new data, longest project, highest ROI.
Depends on the organization, and it depends on kind of what they have, right? I would probably opt for the first one was clean data, smaller
Clean
ROI.
data, quick to complete, low ROI.
Likely it would be the first one, right? None of these projects are boil the ocean projects. I mean, the name of the game is to demonstrate value iteratively, and to build a small project, execute upon it, show the art of the possible. And I think going back to what I had mentioned earlier, you might have 5 initiatives, and you don't really know at the outset how clean or how unclean that data is.